Converting standard form to vertex form. All right, so I will say this is definitely more of an Algebra 2 topic, but the technique that we're going to use is a really important technique, okay, that we're going to come back to when we learn something called the quadratic formula, which is, for some reason, like, I think of the quadratic formula in sort of the Algebra 1 curriculum as this like huge centerpiece, right? It's this long formula that you're going to kind of commit to memory by the end of this year. And the way that that formula is derived is using the technique that we're going to learn today. So we're going to do this by using something called completing the square. But we haven't actually learned completing the square yet. So I'm kind of, I don't think that actually shows up on the video anymore. Yeah, today's the 7th. So I'm kind of using this as a way to teach you guys completing the square. Okay? And then we're going to look at why else is completing the square useful. Because it's useful for more than just converting standard form to vertex form. All right, so I'm planning on doing some problems from your homework tonight, so I'll let you know which ones they are. So problem number 1 is on your homework.
Are we going to copy it?
I mean,
We can't copy it down into our homework.
you can just write the answer. This is problem number 1 on your homework. X squared plus 16x plus 71. This is the standard form, and we're going to convert that into vertex form. So the other day, Dee Dee made a really astute observation, right? We could kind of reverse the process that we use to convert vertex form into standard form. And that is what completing the square is essentially. But I said, well, that's not always going to work exactly. So I'm going to kind of teach you a more general way of reversing that process. Oh, this should say y equals, right? Y equals x squared plus 16x plus 71. So the first thing we're going to do is just rewrite the same equation, x squared plus 16x, but we're going to leave a space, plus 71. And then we're also going to put a space over here. And this trick is going to seem a little weird, I think, at first. But the reason we're leaving this space is so that we can do completing the square. We know that in vertex form, we want to have something that says x plus a number squared. Yeah, it could be a minus, right? It might be a minus, and this one it's going to be plus. Right. So if we look from here to here, how can we make the 16?
Divided by, give it the square root of, or, yeah.
Well, you guys are onto the right idea, but this number, the square root of this number, is going to be this number. So yeah, these numbers have to add up to 16. So all I really have to do is take half of 16 to get this number. Right?
What if you have a number like 17?
Hold on. We'll get there. So if I know that half of 16 is 8, then I can square 8 to get the number that should be right here.
Oh, that makes sense.
But can I just add 64 to this?
No.
No. So if I add 64 here, I subtract 64 over here.
Okay, that makes a lot. Why?
So that I've effectively added 0 to this problem.
So yeah, and then you would have
Plus 64 and minus 64 is 0. But because of the places that I'm adding them in, this becomes this. And then this becomes my constant term, which is plus 7. And then I'm done. That's it.
Oh, wow.
Okay? Now, this was an easy one. Okay. So that's the trick. We started with an easy one. But let's do one more kind of easy one so that you can just review that process. So remember, step one, my markers are giving out on me. Step one was just to rewrite the problem. Step two,
Why was this 7 there?
because that, the 7, that's 71 minus 64.
Okay, I'm writing.
Step two was to figure out our perfect square. Step three, we added the perfect square. Step four,
Wait, what's step 3?
so we added 64, right? Get another one. Step four, we subtracted. Man,
Come on, markers.
Yeah, the one over there by the cleaner is really good.
oh, okay. Let's see if this one works. We subtracted the perfect square. Here we go. Beautiful marker. So we added 64, we subtracted 64. And then step 5, right, we combined the constant terms. So the thing that's kind of weird about this is that step 2 is sort of out of place, right? Remember, I did this before I actually finished this. So we kind of like jump around. We like rewrite the equation, but we leave things blank. Then we write the final equation, and then we kind of jump back and forth from like step 2 to like line 2 to line 3. Right?
And how do you know if it's going to be a positive or minus?
We'll figure that out. Okay? So, let's look at another example. And I'll leave those steps up there. So, this is problem 2 on your homework. And again, I do want you to write these answers in on your homework, but you don't need to show your work.
Wait, Nate. So, if it was like, where it figured out to be, the number was like -3, but the number at the end, the C, made it so that it was a positive number, how do you know that it was -3?
Well, it doesn't matter. If you end up with a positive or negative constant at the end, that's just like the last step.
Oh, okay.
Yeah. Okay, so here's our standard form. We know that our vertex form needs a perfect square. So we're going to say blank minus 5 blank. And remember, these are going to be opposites. We can figure out what the perfect square is by doing what?
Dividing the B by 2.
Yeah, what is b here?
-2.
So what's half of -2?
1.
1, except it's not 1. Half of -2 is -1. So that's how we know if it's going to be positive or negative. If b is negative,
If half of -1 and negative
then this is negative.
times -1 is just no failure.
Right, we'll get there. So then -1 times -1 is positive 1. So I'm going like this, right? Half, and then I'm doing the squared, right? To the second power. But if I add 1 here, I have to subtract 1 over here. So my constant term is -6. So So we've got x minus 1 squared minus 6. You guys see that?
Yeah.
Okay. Now here's where it gets a little bit trickier.
Wait, can you add one over there?
Why do I add one here?
You're adding 0.
Yeah, I can't just add 1 in one place, right? That's just totally changing the equation. So I'm adding 1 and subtracting 1 to kind of cancel it out. I've seen this done where what you actually do is move the constant term onto the other side of the equation. So you'd have like y plus 5 equals all this. And so then if you add 1 here, you add 1 on the other side. And then at the end, you subtract that over. That's more steps. I don't like it that way. But if it makes more sense to you, you can do it that way. So, for example, in this equation, right, you would start out by saying y plus 5 equals x squared minus 2x. It's basically the same thing, except I'm just moving the negative 5 over to the side. They're moving it to the other side of the equation. And then they do what we did. X minus 1 squared. So I know that I have to add 1, which means I have to add 1 to this side of the equation. So then I end up with y plus 6 equals x minus 1 squared, and then I subtract 6 from both sides. So you end up with the same thing, it's just a different way of visualizing it. So if you like this method better, feel free to do it that way. Right? You just start out by adding or subtracting the constant term over to the other side of the equation. Okay? Either way, totally fine. So here's the trick. The thing about vertex form is there's no coefficient on x squared. Okay? So now we're going to do 2 examples. This is problem 3 and 4 on your homework. First we'll do number 3. Y equals negative x squared minus 14x minus 59. So we're going to have to add in an extra step here, and that step makes things a little bit complicated. You're going to have to really follow the math kind of closely.
Can't you divide it or
15.
multiply it by negative 1 first to get
No, that won't work. I mean, in this one you might be able to do that, and then at the end you just have to multiply back through by a negative. But I'm going to show you a different sort of a trick. So let's try this. Y equals negative x squared minus 14x blank minus 59. Blank. What I have to notice is, wait, there's something in front of x squared. So here's what I'm going to do. I'm going to pull out the negative. Negative x squared plus 14x blank, parentheses, minus 59 blank. Now the thing is, when I add something here, I'm technically adding negative 1 times that thing, because it's inside these parentheses, right? This was a negative 14x, but I've turned it into 14x.
So that's gonna whatever.
So if I add a 7 here, I'm really subtracting 7, because it's 7 times negative 1. And which is what I'm going to do, right? So half of 14 is positive 7. So we've got y equals negative x plus 7 squared. We know that's what we want. So 7 squared is 49, right? So I'm adding 49. But remember, I'm really adding positive 49 times negative 1.
Oh, so on the outside you.
So what I like to do is just kind of write it. Technically, I'm doing minus 49 here. So then over here, I have to do plus 49. guys see why I did that? It kind of looks like I added 49 twice, but because of this is technically a minus 49. And then the minus 59 plus 49 is minus 10.
So if we have like a 4, like a negative 4x minus 4.
Yeah, that's what we're going to do next. Well, I think that's what we're going to do. We're going to do like, if we have an A, that's
Yeah,
not
is there gonna be any odd numbers for the x
We'll talk about that. I think there's one on the homework that has odd numbers.
or like prime?
Prime doesn't matter.
Why do I do the decimal unit? Just
Yeah.
where that
All right, can I erase this one? Okay, so remember those steps. This is number 4 on your homework. What if we had 2x squared plus 36x plus 170? Oops, I keep forgetting to write y equals.
That's okay.
Y equals.
Wait, first would be divided all by 2.
No. Yeah, that's a really good guess because when we were factoring, we would pull out the 2, right? Totally. When we were factoring, we would divide everything by 2. We'd pull out that 2. But because we have the y on the other side, if we divided both sides by 2, we'd end up with y over 2 equals. So instead, we're just going to use our method. We have y equals 2x squared plus 36x plus blank plus 170 blank. Okay. What do you notice? There's something in front of x squared. So we have to pull that out from the first 3 terms. So I know I'm going to have y equals 2 times x squared plus 18x plus blank plus 170 blank. So remember, I'm just pulling the 2 out from the first, well, really the first 2 terms plus my invisible term.
minus blank,
Well, no, 'cause it's not gonna
Yeah, we will be subtracting something over here.
but
Yeah.
oh,
Eventually. Okay, so what is my perfect square? Well, I know it's just half of 18, so it's x plus 9. And 9 squared is 81. What did I really just add, though? It looks like I added 81,
You really added half of it.
but I really added 2 times 81, which is 162. So I need to subtract 162 over here. You guys see that?
That's just 8 then.
Exactly. So this over here is just 8. And then because of the way I did this, I'm done. Alright, so we just did 1, 2, 3, and 4 on the homework. I want to say something about some of the other problems on your homework. You might see a problem that doesn't actually start in standard form. Okay? So you might have a problem like this. X plus 9, x plus 10. How could you get that into standard form? If it's y equals, yeah, you would just FOIL that out, right? We would know that's y equals x squared 90, and then we've got 9x plus 10x, so we've got 19x. And then you can convert that. You also are going to see something like this. Y plus 10 equals x squared minus 3x. How would you get that into standard form? Yeah, you can just subtract the 10 from both sides.
And then you can.
So you may have to do a little bit of manipulation of work before the problem is actually in standard form. Be careful, because there's one on there where if you get it into standard form, there's just one problem. It will actually be more complicated. There's one that's already almost in vertex form. So kind of look at what you're given and figure out, am I going to convert this into standard form? Am I going to expand this? What can I do with this? It's going to require some critical thinking, right? Looking at a problem and figuring out what is the best strategy. They're not all going to be exactly these same steps, even though these are kind of the steps that you can use to get from standard form to vertex. Okay. And the other thing is, I would really recommend you take your notes home today, because this is really, these steps can be really hard to remember, right? What?
Can we do like one more?
Yeah.
Two more?
Yeah, let's do one of those on the board. So let's say we had something like,
This is in
yeah, this one's on your homework. Here's a good one. That's kind of an example of this. This is number 11 on your homework. So number 11 starts out looking like this. That is totally not standard form. Right? But I can get this into standard form. And the way I'm gonna get this into standard form is I'm going to subtract 162x and subtract 731 from both sides. And then I'm going to add y to both sides. So on this side, these cancel and these cancel. I just have y equals. On this side, these cancel, and then I have negative 9x squared minus 162x minus 731. Why did I do it this way? Why didn't I just add 9x squared to both sides?
Because it has to be y equals and y can't
Yeah.
be negative.
I wanted a positive y, right? So I could have done that and then just multiplied everything by negative
If
1.
you do get a negative y, you can just multiply it by -1, right?
Totally.
Okay.
Okay, big numbers here. Let's see what happens. So the first thing now, well, it's not really the first thing because I already did the first thing. The next thing I'm going to do is I'm going to rewrite it. Negative 9x squared minus 162x. And then I'm going to leave a blank. Minus 731. And I just draw my blank to remind me. Okay, what's the next thing that I do?
Pull out the negative 162.
Okay, not yet, because why? Yeah, I haven't a coefficient on x squared.
Negative 9, so you pull that out.
So I pull that out.
And you have x squared plus something.
Plus something, right? Because a negative times a positive is going to give me that negative. So we have to figure out 162 divided by 9. 162,
Thank you, Dee Dee. Yeah, no problem.
is it 18?
It is 18. At least according to my calculator. I typed everything in correctly.
Nice. Okay, plus 18x. And then we're going to leave our blank, close the parentheses, minus 731 blank. What am I going to have to remember when I add something here?
It's actually going to be a
that-
positive.
No, that it's times the negative.
That it's times the negative 9. Okay. So y equals negative 9. What goes in my parentheses here? X plus what? Half of 18. Yeah, it's 9. So then what is 9 squared? 81. Plus 81, right? Positive 81. What did I actually just add here? Negative 9
something.
times 81. So again,
It'd be negative 729.
okay. So I really just added minus 729. The opposite of that
Plus.
is plus 729.
But then that's 3 plus 3.
No, negative 3. Negative 2.
731 minus 729.
Negative 3, sorry.
Negative 2.
What?
Negative
Same
2.
difference.
Negative 2. 31 plus, well, 31 minus 29 is 2, but 31 is negative, right? And so this is our final answer. I think the key with these is to really not try to go fast. You want to go pretty slow as you go through these, and just really make sure you're doing each step and you're remembering it correctly.
729 from where does the 81 go? Just leave.
Goes to Narnia, man. Did you
I think I see what you're saying. No, I haven't paused the video. This is all in the video, which is good. So let me show you. Let me show you. We have this, right? Y equals negative 9 times x plus 9 squared minus 2. We can check all of our work by just expanding this back to standard form. So let's do it. What would be the first thing that I would do to expand this to standard form? I would do this binomial. Negative 9 times x squared plus 18x plus 81. That looks pretty familiar, doesn't it? Right? When I expand that, I get that. This was the whole point of completing the square. The whole point of adding the 81 was so that we could get this perfect square. Okay? That's why I added 81. Then I would expand by by multiplying through the negative 9. So using the distributive property, negative 9x squared. And I'm not going to remember the numbers. What was 9 times 18 again? Does anyone remember?
It was 18. No. 162. You that?
162x. And 9 times 81.
81 is.
It was like 729, right? Minus 2. So look, there's that 729 that I had in the other problem. That was the negative 9 times the 81. And then when I combine this, y equals negative 9x squared minus 162x minus 731. That's the problem that I started with, right?
Yeah, but what do you
So I'm checking my work.
with the but I just don't get how you get to negative 9 times x plus 9 squared minus 2. I just don't get how you get
Going
there
the other
from-
way?
Yeah, from x equals negative 9 times x plus 9 plus 81 squared minus 731.
Because I
plus-
purposefully created this. Going the other way, I purposefully split up my numbers so that I would have this perfect
But then
square.
81 just leaves.
No, 81 is 9 times 9. So I turn this into this. Right? Let me use colors. This right here is this right here. These are the same thing. X plus 9 squared is x squared plus 18x plus 81. And so the reason that I added 81 was so that I could turn this into this. Again, talking about going the other way.
Okay.
Does that make sense? That's what completing the square is. And we'll be looking more in depth at completing the square because it's actually a really good technique for solving quadratics as well. Right now we know one way of solving quadratics, which is factoring. You can actually use this to also solve quadratics. Other questions?
Are you going to do another one?
We don't really have time to do another one. I am confident that if you guys use your notes and follow those same steps,
We will have 5 less problems.
you will have success.